So hello everyone, and thanks for joining us on today's webinar, 6 Signs that you should consider predictive maintenance. Today we'll share our experience about indicators that PdM can support companies in facing their current challenges, but also that they can benefit significantly from the implementation. Meet our speakers, Dariusz Broda, Head of Engineering in ReliaSol, and Kasper Huisman, CCO at ReliaSol. They will share both technical and business knowledge and experience with us. So feel very welcome to ask them questions using webinar's chat. The meeting will take around 30 minutes. In the end, we will post a short survey and we will be very curious about your answers. Well, the clock is ticking, the agenda is rich. So without any further ado, Kasper, the floor is yours.
Okay, thanks a lot, Kasia. So before going into today's topics, so the 6 indicators that predictive maintenance could be right for you, I'd like to spend just a couple of sentences on our solution. So in short, we offer an AI-based solution for predictive and prescriptive maintenance called RSIMS. And this platform provides the highest accuracy in the industry for predictive and prescriptive analytics. And actually, we're very excited to announce that we are now introducing an addition to our portfolio, which are called the RSIMS apps. And actually, based on the same AI engine that drives these unrivaled RSIMS platform results, we now offer these standalone apps or packages that allow companies to take really their first steps in predictive maintenance. And because it's app-based, it means that there's an extremely short implementation time. So you're talking about hours. And these apps, they give companies the chance to really start working on, for instance, things like trend monitoring, anomaly detection, correlation monitoring with the data that they have available, and then take their first steps in predictive maintenance at the lowest price that is actually seen in the market. So if you'd like to get an introduction to these RSIMS apps, please feel free to contact your ReliaSol sales reps. But without further ado, let's get into the presentation for today. So 6 signs that you are ready for predictive maintenance. The topics that we're discussing today are about the failures itself, but also we'll spend quite some time talking about data. So availability, storage. We're going to talk about the true impact of failures to your entire organization, and also some operational topics which are related to daily management, human resources, domain knowledge. So if we start with machine or process failures, then there are some very clear signs that machine failures are already hurting your organization or operations. So for instance, the most obvious one, I guess, is downtime. And there's actually quite some industry studies available that show that the average cost of downtime is more than 200,000 euros per hour. So the impact of that on businesses is clearly enormous. But even if you only look into the maintenance cost, then the annual maintenance cost per asset is typically around 5 to 8% of the total price of that asset. So you can probably already do the calculation for yourself. How much that would be for your business or the businesses that you work with. And one of the aspects of downtime is that typically that it happens when you least expect it. And that also means that maintenance personnel actually get to spend less than 30% of their working hours on actual productive tasks. And these 3 things combined, they mean that an average factory loses up to 20% of its productivity simply related to downtime. So if you experience any of this already, then clearly you would like to prevent this from happening again. But if you are not struggling with machine failures, well, of course, that's great. And then you want to ask yourself, do you actually know why that is? And if so, do you then know how sustainable that really is? Because to achieve these, well, let's be honest, great results, you probably need to do investments. And what we see when talking to the companies that we work with, that often the maintenance budgets, they get squeezed. And there's questions around the availability of human resources. So that's both from the number of FTEs, for instance, but also the knowledge that is available with the employees. We're going to spend quite some time on that later in this presentation. One of the things which is of critical importance when you are talking about predictive maintenance is having data available. Darek, can you maybe shed some light on what it actually means? So are the data requirements always the same, or are there any differences?
Yeah, sure. So about the data, in particular, when you speak about the modern technologies like machine learning and artificial intelligence, always the data pops up sooner or later. The data are most crucial for those technologies. But depending on what you need for your PdM, then you might need a bit more and a bit less, or a bit less of data. So in order to know that, first thing that you should ask yourself is what do you want to achieve? If you just want to monitor installation, just looking what might happen there, or maybe you have some failures that you want to accurately predict, and you know what these failures are, and they happen from time to time, or maybe you want to go to some full AI when you want to generate some optimal decisions that will let you avoid the problems or maybe minimize their effects. So that's always the first step. Basing on this, you then can start looking like what is right level for PdM for you. This is already quite technical questions, why one may say, because a lot of data you need for machine learning stuff, but it's not like machine learning is something that you always need. You always need these modern and very advanced technologies. Sometimes they are simply not very cost effective because it takes time to train the models. And in some cases, like for example, in case of rotating machinery, there are a lot of, let's say, typical algorithms that are already on the market that you might use. So in order to choose the right let's say amount of the data that you need at the right level of the PdM, you need to know what is your problem. And now when you know that, let's say there are 3 levels more or less that you might use for the PdM. First one, threshold crossing on one-dimensional anomalies. It's just simply that you observe the parameters, you observe the trend, and you get worried when the certain level is crossed. The main question in this case is how to set the alarm level. So there are 2 simple ways. Either you can use statistics, use or previous data, and look how is that, and set the statistics that say that above this level there's a problem, or you can use the expert knowledge. So if you use the expert knowledge, there is not much data, but you need to have a lot of course, expert of technology info. When you use the statistics, you just need to have some historical data from your machinery. Then if you want to go a bit up, there are dedicated models. They are used, for example, for condition monitoring or non-destructive testing. A lot of methods that are already on the market, known for years. They're usually designed to catch specific failures. For example, bearings. That is very popular things. You have bearings in every rotating machinery, and methods to predict or maybe to monitor the failures of bearings are very well known. So this usually require, you might not even have the historical data for them actually, but they need the specialized sensors or some specialized offline measurements, like the vibration monitoring, thermography, ultrasound. The list might go on and on. And then there is advanced AI. That is very good for the complex machinery, a lot of signal, multi-dimensional stuff, where either there is anomaly detection, so you look whether anything happened at your machinery, or you look at predictive analytics, so you look for the certain problem. So this group, it requires a lot of data, because you need to not only have historical data, but you need to be able to tell something about them. You need to be able to tell whether at which point the machinery was working fine, at which point there were some problems, both from the process point of view or from the machinery point of view, and you need to be able to describe it quite precisely, so to say. A bit more about data is that there are like 3 questions. If you already have them, what you do with them. So this question are the time of the storage. It is how long you should store the data, and what is the frequency, and the way of the storage, and the access. So the time of the storage, the horizon, how long you keep the data, of course, the longer the better. Yeah, if you don't have a problem to gather 10 years of all the data that you have, that is great. Yeah, do it. If there is a problem and you want to minimize the data, you can, for example, minimize it to the level to keep the data only from the last, let's say, capital repair or the big repair of the machinery, because usually during the repair something changes, so not always you're able to use the older data. So there is one of the reasons to make them to keep less data. The other way is if your data are seasonal. It depends, for example, the part of the year, for example, or maybe this monthly. Then try to keep at least a year of the data, yeah, or the length of the season that you can see in your data. And the frequency, it's the sampling frequency of your data. It depends on the process. If the process is very fast, you might need to store every second of the data. Yeah, but it's very slow. It's very, let's say, big machinery. It takes hours to heat up. Then it's probably just enough to keep 1 minute or maybe 5 minutes. It really depends on the type of the machinery. Then the way of the storage. So for the process data, well, you just store it. Yeah, there are a lot of tools on the market, historians, DCS, etc., or cloud systems that let you simply keep your process data in a way that it is usable. A bit bigger problem is with maintenance data. So not only you got to have this process data, you need to describe it. So to describe it is the maintenance data, and we've seen like really tens of different ways of capture of keeping them. So what we could say that what our advice is that keep it simple with the data. And the other thing, make sure same event means same info. These are two things that are very connected. It is when you keep the data, you try to do it in a way that if you have a bearing failure, you always note that there is a bearing failure, and you note the same things. It is what was the temperature, or generally what was the conditions, what were the observations, etc. And always keep it the same, and you keep it very simple. One of the worst things is in some companies, people just let engineers to just note what is happening, and sometimes they provide very short and sometimes very long observations, and then it's very hard to work with it. Also store additional data, observations, working condition, actions taken. And the thing that maybe not here, but it's very important, is that you not only need to have good way to store maintenance data, but you need to train people to use it. Yeah, the process data, you just gather it. For maintenance data, you need engineers or general people in maintenance or in production that need to put this data somewhere. And this is usually the biggest problem. So you need to keep in mind and try to train them. You need to make sure that they know why this data is needed, that is really important, and they use your system, whatever you choose, in the right way. And the access to the data, it's simple, just possible to export to editable format. It's not always, I mean, we might think that it's obvious, but not always. Sometimes it's really difficult to get it in the format that you might work further with advanced tools. So next topic that we would like to say a few words about is failure data, the meaning and cost to the organization. So you should always think whether you know what the real cost of the machine failures, because it's not as easy as you might think. So there are few points. First one, machinery. So of course with machinery, if it's get broken, you need to repair it. Sorry, the slide. It gets broken. This quite obvious. Yeah, you need to repair it, but also every failure, even though the more serious one, means that it's decreased lifetime. It might decrease lifetime of this one machinery, but it might be also decreased lifetime of the machinery that is close to it and was somehow affected by this failure. Another thing, consideration: some machinery takes really a lot of time and huge amount of energy to start again, in particular in energy and chemical sector. Next thing, production. Of course, lost production, that's quite obvious, but also in some areas, the lost material, like in chemical or food industry, if you don't process the material in a given time, it gets lost, for example. And usually people don't count it. Also, some materials might be lost during the startup of the machinery because first part is not with enough high quality, and also production planning always get the problem with this.
Yeah, thanks, Dariusz. And indeed, so then I think we automatically move into the third bullet point, which talks about the overall profitability, because clearly what you described has an impact on the overall profitability. So not just from an input side, so looking into the resources or the energy uptake or the cost for repair, but also on the output side. So there simply is going to be less production, for instance, if you're talking about a manufacturing plant. Talking about work management, then the difficulty or the additional cost that you will see there in an organization is that it's very likely that additional planning work is going to be needed. So where are you going to deploy your staff? And for health and safety, that's actually interesting, because that's what we see increasingly happening with the companies that we are talking to, that the health and safety departments are going to be part of the conversations that we have with those companies. And that is simply because, unfortunately, I would say, maintenance is a very risky business. So there's a relatively high number of accidents that happen when performing maintenance work. And if you then look into, well, I think it's not only the maintenance departments or production departments, but overall there's a very clear lack of staff. So FTEs are very tight. So also, if you do need to deploy for some ad hoc work, either on the maintenance side or on the production side, people, then it's very likely that those same people are needed somewhere else at the same time as well. Looking into environmental issues, then what you should think of is that if a machine is not running optimally, then it's very likely that, as I mentioned earlier, for instance, the energy intake is not sufficient, so it uses more gas or whatever resources than needed. On the output side, the emissions are higher than they should be. And maybe the clearest example, for certain assets, when they do need to be replaced, then that will have a very big impact on the environment, simply from a waste perspective. So related to that, so to the environmental issues, then what we see is that more and more governments and municipalities are implementing fines in case of emissions that are not met. And all of these issues, they lead to all kinds of, let's say, daily management problems. So that brings us to the next slide. So as we were talking about, if you do need to think of ad hoc work, then you almost automatically start to talk about overtime. So it's not just for the maintenance teams. So what you should think there of is that what you always see is that a machine breaks down either on a Saturday night, during the weekend, or on a holiday, so the worst possible time. So you need to deploy people there that you did not plan for. But what also needs to be taken into account by companies is the production side. So if you simply lose production time, you will need to win that back via overtime. With regard to cost of rescheduling, then it is because of the very tightly scheduled maintenance and operations for most companies to minimize cost. It means that if you do need to start apply these outside of normal activities, then first of all, the efficiency, it simply takes a dive. But also, if you need to use machines more than planned, then the wear of those assets will also increase, and therefore the lifetime expectancy of those assets will decrease. And something that Dariusz already referred to earlier, so if you do have the situation that you can use redundant machines, then of course you will also have the startup time, startup cost for those machines as well that you need to take into account. Well, clearly for the last 1.5 to 2 years, COVID is having a very big impact, specifically for production companies or process companies. Then, well, it's needing to deal with having less people on site and more sickness. So then having a system like predictive maintenance that is actually designed to deliver remote work, but also to limit the maintenance, that will clearly help to address these issues. And with regard to daily activities that management needs to deal with, if you think of employee skills and experience, then it is, I think, a well-known fact that more experienced and skilled employees simply do increase the productivity of a company. So if you then have a predictive maintenance system that can take the settings or adjustments from the skilled operators, but also of the adjustments, for instance, that a maintenance employee does. And if you can take that as a blueprint to provide to the plant, that will lead to an overall production improvement. So if you continue on that, then if you do lose that domain knowledge, so if you lose that knowledge of those skilled employees, then it's a clear fact, then you are losing money. And I would say that for most companies, then sharing that knowledge, so where a senior operator or senior maintenance employee trains more junior people, that's probably going to be part of most of the plans that companies have. But at the same time, a great operator doesn't necessarily make a great trainer. And also what you see is that those type of activities, so those handover activities, those training activities, they typically get pushed out the earliest when there's some kind of everyday issue that's going to define the list of priorities. Talking about employee turnover, well, of course, that's normal, that's good. But it can also lead to risk when you do lose those competences. And earlier this year, I had the privilege to talk to a Dutch maintenance school where maintenance professionals were trained. And there, one of the teachers was saying that they had this year 40 people graduating, but the demand from the industry just in that direct vicinity of that school was already 10 times higher. So the companies in the direct vicinity were asking for 400 maintenance employees. So if you then look into some of the overall challenges that we see when we are talking to companies, when we're talking to our customers, then it is, first of all, the increasing maintenance cost. So for a typical company, the maintenance cost ranges between 15 up to 40% of their total production cost. And as I said earlier, the downtime costs, they are increasing as well rapidly. The average factory loses up to 20% of their productivity due to downtime. And those health and safety aspects that I spoke about earlier, it's a not so well known and also not nice fact, but up to 30% of manufacturing fatalities are actually directly linked to maintenance. And something that we see, especially in Europe, having a very big impact. So earlier this year, the European carbon pricing reached 50 euros, then it went to 60 euros, and currently it is expected then in not the too distant future is going to be at 90 euro per ton. And that clearly will have a very big impact for companies. So what's the solution then? Well, predictive maintenance, it provides some very tangible benefits. And what we always say is that predictive maintenance or prescriptive maintenance, it's definitely not for every company, but when it is, then the return on investment, it is a no-brainer. So that's always extremely favorable. So it's the maintenance cost, what you see. So those problems that I spoke about earlier, those can be reduced with 30%. Because you know better what to plan for, you can lower your inventory cost. The asset lifetime is extended. Maintenance planning time is reduced up to 50%. And the overall equipment uptime and availability is also significantly increased. If you talk about return on investment, then it's really clear, and often you're talking about months, you're not talking about years to get the return on investment when you talk about predictive maintenance. And if you talk about productivity, the increase that you see there, then it can be around 25% of increased productivity. The safety risks to be reduced with 14%, and also that carbon footprint that we saw the impact of. Then with a system of predictive maintenance, then you can reduce your waste with 10 to 20%, and the asset lifetime is extended. So, of course, we know that these challenges and also these results, that they will differ per industry. What we have at ReliaSol, we have very fast experience with actually multiple industries that we helped to solve their problems, but also to deliver these results that I spoke about. What you can do is you can go to visit our website, and of course you can sign up for a free demo with our team to find out how predictive maintenance can meet the specific needs for your industry, for your processes, and for the problems that you have. So yeah, with that, I'd like to hand over again to Kasia, who will take you through the survey that you already spoke about?
Yeah, thank you, Kasper. Thank you, Darek. We made a promise to keep it in 30 minutes, and we're shocked because we are just about to make it. So for now, we will indeed post a short survey. I hope you will see it in a minute. We are very curious about your answers, so let us know what do you think about the questions. They're very simple, so the survey will last just for a few more moments.
I see. In the meantime, I see a question. Darek, maybe you can. There's a question. How do you visualize all the data together, or do you get a report?
So visualizing all data together is, of course, a problem. There is the brutal solution. Maybe because the report like this, when you can put all the data on the reports, a lot of them. There is a technical solution. There are methods which you can use to reduce the dimensionality, and you can, of course, it also limit the information, but you can show in like 2 or 3 dimensions the information that are stored in like 10 or 20 dimensions or even more. But what we think that is usually best is to show only the information that are the most relevant, because you just want to go through the data that you have. There are also usually DCS let you, historians let you to do it. But our philosophy is that we want you to focus on the data that is important, that something is happening there, either something simple, statistical changes, some simple anomalies, or something advanced, like that information from advanced ML algorithms. And that's the way that we usually handle this. And the reports, of course, actually with our software, you can get the reports with summaries, but also with the detailed information, with the raw signal, however you prefer to go for it. I hope that's the answer that fulfills the question.
Thank you, Darek. Thank you for answers to our survey. If you have any more questions, we still have a few moments for them. In the meantime, thank you for joining us today. We hope that after this meeting, you know if the PdM is a right tool for you and for your companies. And if you do have any more questions, because this was obviously just a sample of Darek's and Kasper's knowledge and experience, we'll be more than happy to answer them. So please do not hesitate to contact us, for example, by marketing@reliasol.ai or our speakers directly. And just to give you a heads up, our next webinar will cover a new light approach to PdM tools that Kasper mentioned a little bit. So stay tuned, and well, we hope to see you soon. And if we don't have any more questions, thank you for today and take care. Thank you, Darek. Thank you, Kasper. Thank you for joining us.
Thank you. Bye-bye.
Yeah.